Here we go with few problems on Rolle's theorem. First question we have, verify Rolle's theorem for the function f of x is equals to log of x square plus ab by x of a plus b in the given interval a comma b, and where a is greater than 0 and b is also greater than 0. It means the both values of a and b are positive, they are greater than 0 and not equals to 0, and they are not negative values, so the both a b values are positive. And the next, first write the given information, that is given f of x is equals to log of x square plus ab by x of a plus b in interval a comma b. Then f of x is equals to log of x square plus ab minus log x into a plus b. So we have the formula log of x by y can also be written as log x minus log y. It means log of the numerator minus log of the denominator. So if we treat with this function x square plus ab as a numerator, that means as x, and then denominator x of a plus b as y, then we get the function as a log of x square plus ab minus log x into a plus b. Then furtherly, f of x can also be written as log of x square plus ab minus of log x plus log of a plus b. That is, log ab can be written as log a plus log b. So the two functions log x and a plus b are multiplying together, so we can write it as log x plus log a plus b. So then next here, f of x is equals to log of x square plus ab minus log x, and when we multiply this minus with the plus, we get it as minus, so that is minus log of a plus b. And the first condition we need to check is whether the function is continuous or not in a given interval a comma b. So it is not equals to infinity for all x belongs to a comma b, because a is greater than 0. When a is greater than 0, it is defined. For negative values and for 0, we get an infinite value, and logarithm is not defined. So the given the condition is the both a and b values are positive. So it's not going to be infinite for any value of the x belongs to a comma b. So in between a and b, the value of this function is not going to be infinity. So we can write a point as, therefore the function f of x is continuous in the interval a comma b. And the next we need to check is whether the function is differentiable in the given interval or not. So that is, we are differentiating the function, logarithm function, so that is f dash of x, that equals to, so we are derivating this function, the logarithm function, so log of x derivative is 1 by x. So treating this whole function as x, first we differentiate the logarithm function, that is log of the function is, differentiation is 1 by x square plus ab by x of a plus b, and multiplied by, we have to differentiate the inside function of the logarithm, that is, so it is in the form of u by v. We have to use the u by v method. So that u by v method comes as, in the denominator we get denominator whole square, that is x of a plus b whole square, and in the numerator, denominator into differentiation of numerator minus numerator into differentiation of denominator. So the denominator is x of a plus b, and we are differentiating the numerator function, that is x square plus ab, minus numerator into, that is x square plus ab, into differentiation of the denominator, that is x of a plus b. Then here f dash of x is equals to 1 by x square plus ab by x of a plus b into x of a plus b, differentiation of x square with respect to x is 2x, and differentiation of this ab with respect to x is 0, because ab are the constant values, minus x square plus ab into differentiation of this function x of a plus b, that is comes as a plus b, and divided by x of a plus b whole square. Then here, if it goes into the numerator, we get it as x of a plus b by x square plus ab into 2x into x is 2x square, and from this both term we are taking a plus b as common. So we get a plus b of 2x into x, 2x square, minus x square, and minus is multiplied with the inside, that is ab, then minus into plus is minus ab, and in the denominator x of a plus b whole square can be written as x square of a plus b whole square. Then here 1 by x square plus ab into x of a plus b into a plus b, it becomes x of a plus b whole square, and 2x square minus x square is x square, minus ab in the denominator x square of a plus b whole square. So 1x in the numerator and another x in the denominator gets cancelled, and a plus b whole square and a plus b whole square also gets cancelled. So finally we get x square minus ab by in the denominator x of x square plus ab. So this is a f dash of x. It means we differentiated the function f of x. We got it as x square minus ab by x of a square plus ab. And this is not going to be infinity for any value of x which are belong to the open interval a comma b. So whatever the values you take a and b, so you will never get the infinite value. You should not take the values of a and b. You have to take the values which are there in between a and b. So that's why we have written the open interval for all for differentiable condition. For continuous we write it as a closed interval, and for differentiable we write it as open interval because a and b values are not included. If you write the a and b values in the denominator, it's going to be 0. So inside the inside integers are taken in between the a and b. So this value is not going to be infinity for all x belongs to a comma b. Therefore f of x is differentiable in open interval a comma b, and a is not equals to 0 and a is not equals to any negative value. Then we have the third condition here, f of a should be equal to f of b. So the here interval is also closed interval a comma b. Then f of a should be equal to f of b. Now substitute a in the function f of x, that is log of x square plus ab by x of a plus b. When you substitute a in the place of x, you get it as log of x square a square plus ab by a of a plus b, and that equals to a square plus ab by, just multiply this a with the a plus b, you get it as a square plus ab. The numerator and denominator both are same, so you get f of a is equals to log 1, where log 1 value is equals to 0. Therefore f of a is equals to 0. Then f of b, so substitute b in the place of x, you will get it as log of b square plus ab by b of a plus b, and that equals to log of b square plus ab by b into a is ab and b into b is b square, so b square plus ab, and then f of b is equals to log 1, that equals to 0. Therefore f of b is equal to 0. So we can write f of a is equals to f of b is equals to 0. So the third condition is also satisfied. Therefore 3 conditions of the Rolle's theorem are satisfied. That is, first one is continuous, and second one is the function is differentiable, and third is f of a is equals to f of b. So there exists a point C such that it belongs to the interval a comma b, and the differentiation of the C is equals to 0, that is f dash of C is equals to 0. So f dash of C, f dash of x we got it as x square minus ab by x of x square plus ab. So in the place of x we are substituting the point C. C is equals to c square minus ab by c of c square plus ab, that equals to 0. So c square minus ab is equal to this whole numerator term, when it goes to the right hand side it multiplies with 0 and it becomes 0. Then from here c square is equals to, send this minus ab to the right hand side, we get it as plus ab, and then from here c is equals to root a plus b. The c belongs to a plus b, and here we can get it as plus or minus, and we are not taking minus root ab because the interval is from a to b, and we know that a value is greater than 0 and b value is greater than 0. So the in between the a and b, it's going to be always positive numbers. So we have these 2 conditions. So that's why we are not taking the negative of the root. So c is equals to root a b, that belongs to the open interval a comma b. Therefore hence Rolle's theorem is verified. Verify Rolle's theorem for f of x is equals to x minus a whole power m into x minus b whole power n, where m and n are positive integers in the interval a comma b. The given function is x minus a whole power m into x minus b whole power n in the interval a comma b, and we have to check whether it's continuous or not and differentiable or not. So given in the question, the given as m and n are positive integers, and we know that this is a polynomial, and we know that every polynomial is continuous. So for the positive powers, so we have to check whether it's a m and n are positive powers or not. But in the question they mentioned that m and n are positive integers. So they have already mentioned that m and n are positive integers. So we can directly give a statement as every polynomial is continuous for the positive powers. So it is a continuous function. Therefore, the function f of x is continuous in closed interval a comma b, and it's not going to be infinite for all the values of x which are belong to the interval a comma b. And we need to check whether it's differentiable or not. So f of x differentiation, that is f dash of x is equals to, here the function we are applying UV method because x minus a whole power m is one function and x minus b whole power n is another function. The multiplication of two functions, here we are applying UV method. So first function into derivative of second function plus second function into derivative of first function, that is x minus a whole power m into d by dx of x minus b whole power n plus x minus b whole power n into d by dx of x minus a whole power m. So here x minus a whole power m, derivative of this function, we know that derivative of x power n is n into x power n minus 1, and inside this function also we will derivative it, that is dou x by dou x, and we will get it as 1. So directly we will write it as n into x power n minus 1. So here also the same, x minus a whole power m, derivative of this is n into x minus b whole power n minus 1, and x minus b also we derivative it, but when we derivate x minus b whole power x minus b with respect to x, we get it as 1, and that 1 will be multiplied with this, again we will get back to n of x minus b whole power n minus 1. So that's why we are not writing this x minus b derivative. And then here x minus b whole power n into derivative of the second first function, that is x minus a whole power m. So that is m into x minus a whole power m minus 1, and here also we derivate inside function, again you will get back to 1. And here n into x minus a whole power m into x minus b whole power n by x minus b whole power minus 1 can be written as 1 by x minus b. So we are writing it in the denominator, n into x minus a whole power m into x minus b whole power n by x minus b, plus here also the same, m into x minus a whole power m into x minus b whole power n, denominator we get it as x minus a. So from these both the terms we are taking x minus a whole power m and x minus b whole power n, we are taking it as common. So when we take it as common, we get f dash of x is equals to x minus a whole power m into x minus b whole power n, and here the leftover is n by x minus b plus here m by x minus a, and this value is not going to be infinite for all the values of x which are belong to open interval a comma b. So excluding a and b, in between the a and b whatever the integers are there, for all those values this value is not going to be infinite. So here we give a conclusion point as f of x is differentiable in open interval a comma b. So whatever the values you substitute for x in between a and b, this value is not always not equals to infinite. Then second condition is also satisfied. We have to check it for third condition, that is f of a should be equal to f of b. So substitute a in the place of x in the given function, we get f of a is equals to a minus a whole to the power of m into a minus b whole to the power of m whole to the power of n, and here a minus a whole to the power of m is 0 and into a minus b whole power m, so it's n, and whatever the you will multiply with 0, it becomes 0. So f of a is equals to 0. Then here f of b is equals to b minus a whole to the power of m and b minus b whole to the power of n. So this value is 0, and when it multiplied with b minus a whole power m, it becomes 0. So f of b value is also 0. Therefore, f of a is equals to f of b, and the both values are equals to 0. Here, three conditions of the Rolle's theorem are satisfied. That is, first condition is the function is continuous, and second one is the function is differentiable, and third condition is f of a is equals to f of b. Three conditions are satisfied such that there exists a point C, and that point C belongs to the point interval a comma b, and the point C lies somewhere in between a and b, and the derivative of C, function C, that is f dash of C, is equals to 0. So in the place of x, if we substitute C, we get f dash of C, and that equals to C minus a whole power m into C minus b whole power n into n by C minus b plus m by C minus a is equals to 0. So here we have three terms, and these three terms, each term is equals to 0. Then C minus a whole power m is equals to 0, and C minus b whole power n is equals to 0, and then third term n by C minus b plus m by C minus a is equals to 0. So from here C minus a is equal to 0 and C minus b equal to 0, and here if you take the LCM, n into C minus a plus m into C minus b divided by C minus a into C minus b. We are taking the LCM of the denominator. That equals to 0. Then from here, send minus a to the right hand side, you get C is equals to a. And here send minus b to the right hand side, you get C is equals to b. And here in the denominator, when you send it to the right hand side, it multiplies with the 0 and it becomes 0. Then from here, m of C plus b plus n of C minus a is equals to 0. And from here, m into C is mc, m into b is minus mb, plus n into C is nc, and n into minus a is minus na is equals to 0. And then from here, mc plus nc is equals to, send na and minus mb to the right hand side, you get na plus mb. Then C, from these two terms you take C common, you get it as C of m plus n and is equals to na plus mb. Then C is equals to mb plus na. When you send m plus n to the right hand side, it divides, then divided by m plus n, and that belongs to the interval a comma b. So the values of C, we got it as C is equals to a, b and mb plus ma by m plus n, and these 3 points are belongs to the interval a comma b. It means the values of C are a, b and mb plus ma by m plus n, and these 3 points lie somewhere in between a and b. So the hence Rolle's theorem is verified.